Assalamualaikum warahmatullahi ta'ala wabarakatuh. So today we will be present for our subject power system protection, which titled Strip of Multiple Transmission Elements at 11 port 275 kV substation at March 2022 in South Australia. Okay. So this is our team member. We have 4 of us, which is the first one is Muhammad Abdul Rahman, and then Athira Mazlan, Mark McStain, and I am Shafika Samsudin. Alright. Next slide would be the incident detail, incident classification, and the generation and customer loss impact. Okay. So for this case, this report relates to a reviewable operating incident that occurred on 28 September 2021 in South Australia. The incident was a non-credible contingency event involving the simultaneous trip of the Devonport Bungama 275 kV line, the Devonport 275 kV West bus, the Devonport Mount Lock 275 kV line, and the Devonport number 2 synchronous condenser. Okay, so for the incident classification, the protection or control system, the mal-operation of protection system. And the last point is for the generation and customer loss impact. There are 2 points, which is the first one is there's no generation was lost as a result of this incident, and no lot was lost as a result of this incident. Okay, next presenter will be Mark.
Okay, I'm Mark Maxine. I now continue to our next slide, which is the slide for our slide presentation, table of contents. Okay, the first part of our presentation is the sequence, which is summarized for the incident that we are studying. Okay, the second part is the main cause of how the cause of incident is happened. Okay, the third part is the preventing. Okay, which is the sum of solution that we have discussed throughout the study that we would like to avoid it's happening. Okay, last, the fourth part is conclusion. We have to conclude all the steps and the preventing that may cause it happening again. Okay, next. Okay. For the first part, we'll explain a bit about incident key event. Okay, which is when did it happen? Okay, first of all, you may know in this custody implement trip of multiple transmission element, which is happened at the Devonport 275 kilowatt substation. The date of this incident is happened by the 28th of September 2021 on the Bungama. First of all, this happened by the time of 3:55 p.m. Okay. First of all, it is happened as a lightning strike cause a U phase, a one phase, which is at U phase fault on the Bungama Devonport 275 kilowatt line, and this fault was created within 65 milliseconds. In the next incident causes is by the 5:30, which is 7:30 p.m. Okay, the Devonport 205 kilowatt West bus and the Devonport Mount Lock 205 kilowatt line were returned to service, which is temporarily open and then it closed again. Okay, the third part is within the 8:25. If at night time, the electronet advises the cause of incident has been identified and isolated, then it was unlikely to reoccur in the same located circuit. Within 20 minutes later, which is at 31 p.m., the Devonport number 2 synchronous condenser was returned to service. which is back in just the supply pack. Okay, this I will like to pass to the next presenter.
Hi, my name is Muhammad. Okay, I will explain about the main cause. How could it be? So the main cause for the Bungama, Devonport 275 kilovolt line distance and differential protection system operate correctly, clearing the fault caused by the lightning strike within 61 milliseconds. And then circuit breaker fail, CBF. It is circuit breaker CB6564 and CB6565 operate unexpectedly. This CBF protection operation trip the Devonport 275 kilovolt west bus, the Devonport Mount Lock 275 kilovolt line, and the Devonport number 2 synchronous condenser. And then the third one, the resultant of fault current caused by overload element to unexpected pickup in the set 2 Devonport number 2 synchronous condenser generator step-up transformer, which is GSUT protection system. This transient overload element pickup caused by the CBF protection on both CB6564 and CB6565 on to erroneously pick up even though no trip signal has been sent to this circuit breaker. Okay, here is the circuit, the incident diagram prior to CBF protection operation. So here is the CB6565 and CB6564, which is according to the report, it failed to operate correctly. So when the incident happened, CB6564 turned to open circuit breaker, causing the other circuit breaker here is in open condition too. So this is the circuit diagram for the incident happened in Bugama power plant. So here I will pass to the next presenter, which is Nurul Atira.
For this slide, we want to prevent this accident to happen again. Next. First, all protection system with overload protection setting identical to the Devonport number 2 synchronous condenser have been disabled. Second, Electronet is reviewing the standard logic for this protection implementation to avoid similar issue in a future protection system that use the same logic. Until the review is complete, the overload protection for the Devonport synchronous condenser will be provided by their respective GSUT set 1 protection system. Electronet review is expected to be complete in Q2 2022. The third, the Robertson synchronous condenser GSUT have a different protection relay and protection setting to those used on the Devonport synchronous condenser. Therefore, the Robertson synchronous condenser are not impacted by the sighting issue identified by Electronet during the accident. Next. Okay, this conclusion for this accident. For this conclusion, lightning strike is the main cause of the single phase fault on the Bugama Devonport 275 kilovolt. Next, the simultaneous trip on of the Devonport 275 kilovolt waste bus was caused by the incorrect operation of the CBF protection due to an overload element pickup on the Davenport number 2 synchronous condenser GSUT set 2 protection. Thank you.